They're young and they're in different fields of manufacturing. Chris is making cameras and testing them. Rashida is involved in the computers industry, and Megan is in biomanufacturing, which is an up-and-coming field in North Carolina and has some really awesome stuff going on. We actually were classmates in biomedical ethics class over the summer, so it's nice to see her here. But I'll give y'all a little background about our panelists. Rashida graduated from NCSU with a bachelor's degree in industrial engineering in 2002, and a master's in industrial engineering in 2003. And at IBM, she leads strategic development management and supply chain strategy. And she's worked with clients around the world, promoting IBM and improving their product. Chris graduated from NC State with a degree in industrial design in 2010. During his undergraduate career here, he worked for Hard Parts Design, first as a fabricator and then as a designer. And now with GoPro, he tests products and gets to do some fun stuff. GoPro is a type of camera that you can mount and it will take pictures as you go. It's a really cool thing for sports and outdoors enthusiasts. And Megan just graduated from NC State over the last spring. Her major was in chemical engineering, and she earned a minor in biomanufacturing over at the BTech Center, which is right down the street. She hopes to get her master's degree at NC State in 2016. And she works with Fujifilm's biomanufacturing. Everyone's going to talk about all their experience in the field. And we do have a change in moderator. Our first panelist moderator was not able to make it, so Ali Khalifa from the second panel will be talking. Now, Ali has an interesting career. He works with Gamal Design, and the major thing that they produce is this product called T-Stick. It's it's a product that helps brew loose leaf tea, but his company deals with advanced design for sporting accessories as well. Some of his clients are Nike and Shrek, and he has to travel a lot to Asia to deal with some of his clients. So our panel, they're young and they have a lot of cool experiences. So come on up, take it away.
Garth Davis, who is the moderator of this panel, is going to be moderating Allie's panel later. So just to
Nothing like thinking on your feet, so here we go. I'm Ali Khalifa, and I will be moderating this panel. Forgive me for not being 100% on things. I need to meet everybody here. But I would like to just quickly talk about why I'm here. I was really going to be talking at the next panel discussion and talking about manufacturing, and it's specifically how it relates to a lot of the modern manufacturing methods and how things are going, and what is the preparation that happens at the university level that allows you to get ready for that. As was mentioned, we have a few of our own products like the T-Stick. Primarily what we're doing is at Camille Design is design engineering consulting. And so we're working with many brands across the world and manufacturing in a variety of locations. And it's a really interesting thing. I'm just going to reflect quickly because when I think about my university experience, I got a degree here in industrial design and mechanical engineering, so I was kind of racing on inline skates between the two schools all the time, and a little bit of an insomniac. I guess that part hasn't changed now that I'm a dad. But what was interesting was to see how much attention there was on manufacturing, or sometimes the lack thereof. And it was a real trick, all of a sudden landing my first job and learn the world of mass production. And you design things differently when you know you have to make them, right? You can make any recipe in the world or grab a recipe off the internet, and when you realize the ingredients, the things, and the tactics that go into putting something together yourself, you start to change the process. So it was a really interesting thing to see that manufacturing really was affecting my design engineering skills. And then things started to change in terms of manufacturing, and I think what's great about the folks you're going to be talking to now is to see that changing landscape. So just when, after 20 years of designing, engineering, manufacturing products for the consumer products market, you feel like you're beginning to get it, and then like the whole world turns upside down. And everything I do about manufacturing really doesn't apply anymore. And so here we go, I'm back in school again, I guess. So because it's not really, it would be sort of a farce for me to really introduce all of you guys. I'd like for you to just maybe introduce yourselves, and maybe we can do a few minutes each and talk about, first of all, a little bit about your education background at NC State, and then a little bit about what you do now. And after that, we'll have some short questions, and then each of you then can respond.
All right, so good afternoon, everyone. My name is Rashida Hodge, and as was earlier mentioned, I graduated from North Carolina State with a bachelor's in industrial engineering, and I also did my master's in industrial engineering as well, and I finished that in 2003. I currently work at IBM, and I am the manager of our strategy and innovation team for all of our supply chain operations. So from an IBM perspective, the supply chain means different things to different companies and to different people. For IBM, this encompasses, for example, all of our procurement, so how we source, how we buy, how we work with our suppliers, our manufacturing, our engineering, so think, packaging engineers, manufacturing engineers, our inventory teams that work directly with manufacturing, our demand and supply. So I really work with our senior leadership team in terms of what's our strategy in terms of supply chain for the future. Where do we see supply chain moving to? How do we support that? And how do we partner, with our suppliers and through the extended supply chain and really across the multi-enterprise to make sure that we have a very competitive supply chain as well. Currently, I'm also at that blue school down the road in Duke getting my MBA. So I'm getting my MBA, and I'll be finishing up in December of this year. I'm originally actually from St. Thomas, the U.S. Virgin Islands. I came and started school here in 1998, and came from 32 square miles. I came to Raleigh. It was a great experience, loved it, hence why I've stayed. I've had the opportunity to travel immensely with IBM. I've worked in Shenzhen, China, in one of our large manufacturing sites there, where we formerly made the ThinkPad. We've now sold that to Lenovo, but I've worked there with our team in China. I spent 3.5 years in Europe, where I worked in Bratislava, Slovakia. So it's like in the dead center of Europe, working with our extended supply chain teams, supporting our services business. So I've had a lot of different roles, and also globally supporting our extended global supply chain.
Yes, I'll take this one. So I graduated chemical engineering this summer. So I am very fresh out of school, so not nearly the list of things that you've done. My experience is more internship, co-ops, and more recently a full-time position. So I guess I came into NC State thinking that I'd already thrown being a doctor out of the wind because I was terrible at blood, and I really wanted to help people, but that was not the way to do it. So I was actually biomedical engineering and decided coming in if I would make some stuff, make people's lives better. And then I found BTech. And by that I mean they found me. There's this lady named Winnell there, if anybody's ever been in the building, and she's got a humongous presence. So I was in the brickyard, and I met Winnell, and I realized that chemical engineering with a focus on biomanufacturing was much more where I belonged. So very good with science, very good with math, always wanted to build things. And chemical engineering is so versatile. So I guess a lot of people don't know what chemical engineering is. I didn't know what it was until I was like a senior. But it's the process of making things with chemicals and fluids, and maybe not fluids anymore, but anything with plastics or medicines or foods, there's a lot of chemical engineering involved. So you can take the degree and go pretty much anywhere. And so I found BTEC, Biomanufacturing, and they kind of introduced me to an internship with Baxter Healthcare where I kind of learned what the FDA was. They introduced me to an internship with Novartis, Vaccines and Diagnostics, which is right in Holly Springs. They make the flu vaccine using cells, which is a kind of new technology. Traditionally, it's made using eggs. So they use a cell culture to make the flu vaccine. So I got to do an internship there in their bulk manufacturing area. At Baxter, I was in manufacturing support, so I supported a line of manufacturing. And then eventually I ended up with a co-op with Biogen IDEC, and they are a huge biopharma company. They've got quite a presence. They make things for multiple sclerosis. So all of this I did kind of with my degree and with my minor, and it just set me up to meet a lot of cool people in a lot of cool places. And eventually I found Fujifilm Diosynth Biotechnologies, which is a huge name, but essentially it's just the biologics contract manufacturing organization that Fujifilm bought a couple years ago. It had a bazillion different owners. If you refer to it as Diosynth, you'll find the history of the company. But it's contract manufacturing, and we make anything that our people bring us, and with any kind of cell line. So it's very exciting. I've been there for almost a year now. I'm in their cell culture development group, which is part of the upstream development. I'm kind of in both. And so, you know, more recently been developing processes to make vaccines and antibodies and lots of those complicated medicines that you have to inject into you. So stuff that's more complicated than you can swallow because your body would break it down. Things that go straight into the bloodstream. Anything that could go straight into the bloodstream is the kind of stuff you make. So been doing that for almost a year.
And Chris?
Yeah, can you guys hear me?
Sure enough.
Good? Awesome. I'm here in San Mateo, California at GoPro. You guys familiar with GoPro at all? Heard of it? Maybe we make these little things, these wearable cameras. Kind of recently came out of nowhere, about the last year or two, not very much. Apparently the best looking app in the world, so they've come a long way in the last few years. So it's pretty exciting. But I started at NC State in 2005 in first year college. Kind of fumbled around there for a little bit, jumped into architecture, and then found industrial design, where I graduated with. Just took some experimentation to find out what my strong points were and kind of end up in the right road. After that, I guess actually during school, I did an internship at a company called Mark Parts Design doing attachments, and then another internship here at a power tools company at TTI. They make Milwaukee power tools, Rigid, Ryobi, Craftsman power tools. They pretty much own most of Home Depot's power tool aisles, so pretty big company. They invited me back to work after I graduated. The speaker's kind of repeating what I'm saying to me. It's it's throwing me off a little bit. I went to
Any better?
let's see. It's a little better. I'll learn to deal with it. It's okay. So they invited me back to work after I finished the internship, and I was doing concept design for them. So it's kind of like a new product invention. Come up with an idea, build one, test it out, see if it's worth pursuing, and then if it is, we put it on the production. So I worked there for 3 years, and recently moved over here to, that was in South Carolina. I recently moved to California to work for GoPro. So it's been neat here. It's pretty much the same job. I'm a product designer, so we test. We kind of come up with a new idea that we want to test out. We'll build some prototypes, go out, test them out, and see if we like them. Kind of refine ultimately if it's good enough, we'll end up taking it into production and putting it to market.
Great. Okay, well, maybe we'll just pass this back and forth. I just had a few questions for everyone. One of which is just reflecting back on school a little bit. What's the one thing that you might use once a week that really is a tool that you all developed in school? What is one thing you go to, whether it's a textbook or it's some handwritten notes or it's some kind of process, or what is one thing from school that you still draw on quite a bit? And Rashida, put you on the spot first.
Okay, sir. So it's not a textbook. I would say it's, being an engineer, I really learned how to solve problems, how to attack a problem, how to address a problem, and most importantly, how to collaborate with my peers in solving that problem. If I look at, the things that I do on a daily basis, I do nothing alone, right? Nothing really comes to life unless I'm able to effectively, look at that problem, one, be able to see, what's going on with it, who's involved, what could be the potential, issues, solutions, and then most importantly, who do I need to get involved to help me to get to that solution? I have learned through trial and error, failure and success, that if you try to attack a problem independently, in your own cocoon and in your sandbox, 9 times out of 10 for me, it just didn't work. So collaboration has been just really important, and I think, especially for me, when I was doing the Usher Engineering program, I really enjoyed the team assignments going through it. At that time, I didn't, probably, right? But I learned a lot from that experience. How do you work with other people? How do you also take someone else's ideas, and you all work together to make them, a solution? And it sounds very cliche, but it's actually really hard. Right? It's actually very hard sometimes to be able to apply that, especially when you're working and you have many type A individuals together. And even sometimes, I'm going to be very truthful, as engineers, we tend to say, okay, I have a great solution, this is what I came up with, and I know that this is the right way. And it's not always the case, right? So we also have to learn that, yeah, there are other people with, different skill sets that also bring good, healthy fruit to the table. And how are you able to really work together to have a solution that is beneficial for everyone?
And my answer probably mirrors Rashida's almost to a T. So I did the entrepreneurship senior design here last year. So the EI, the EEP, working with a multidisciplinary team. And I learned so much. I think the thing I use most often is really Google Calendar, which I know sounds like a little intense. But being able to schedule everybody, get everyone on the same page, and just communicate. So I'm a planner. If I don't plan something, if it's not in my calendar, it's not going to happen. I don't remember things like that. So everything I do is written down. And so I learned that a lot of it was discovery through senior design, like what worked for me when I worked with a group and what kind of group dynamic that I find most successful. Because I was a girl in chemical engineering, and I had a guy in mechanical engineering, and a guy in electrical engineering, and a guy in textiles engineering, and at some point we had a girl from industrial design in another county. And so it was people in every different kind of, thought process at any moment. Somebody could have a test, somebody didn't have a test, somebody had a really good project in one class. Everybody was somewhere different. And so being able to schedule things, especially working for a contract manufacturing organization, we are so busy all the time. There's new projects in. I swear, we have a new project every month for fermentation, at least, and cell culture about this theme. So there's always something new going on, somebody's doing something different, you're working on something else. So being able to work with people and communicate and schedule your time and your thing and speak to them, understand what they're doing. You can't work alone. There's no way. So I think that was probably the biggest thing that I use from day to day.
So my technical experience at State, I think the most tangible thing I can give you is shop skills, actually, surprisingly. I was kind of a shop rat in design school. Really enjoyed learning on and testing, building things, and that's really paid off in professional work. is that it's not a skill that a lot of people have. A lot of educated people that focus on kind of that area. And they know a lot of the math, they know a lot of the physics, but they can't get in there quickly, prove out ideas and concepts. With product development, one of the big things is learning quickly and getting your final design quickly. Be able to hack something together and test out to see if your basic ideas before you go through production design and that kind of stuff. So really just knowing what you can do in the shop and how to do it, being able to get in there and hack together things, even really rough prototypes, just to see if it's going to work at all. It's a really good skill. And the design school has a really good job space. Taking advantage of that was
So I know one of the precursors to this event was an article written in the Technician that was looking at the Emerging Issues Forum and the Made in China pens that were distributed to the event. And I wanted to just touch on that a little bit and make sure we addressed it in a way that we all understand, or at least it relates to each of us in our professions. I think each of you are working in really different industries, and it sounds like also in different marketplaces. But if each of you could just think a little bit about what impact the global marketplace is having on the decisions that you're making, as well as the manufacturing environment. So in terms of like global manufacturing versus local manufacturing, and global marketplace versus local marketplace, where is most of your work, and what implications do you see between those two things? We'll mix it up. I'll put Megan out there first.
Hey. So that's a loaded question. So working for a contract manufacturing organization, like you see everything. You see something new every day. You see big pharma as our clients that, they're just taking a risk on some small molecule that they don't know if it's going to work or not. It's high risk, not necessarily high reward, could be. So it comes to us. So when it doesn't pass the clinical trial, they can just, cut it there. And then you see those small startups and they have one drug and like that's it for them. And so we see a movement, I guess, locally. Biomanufacturing is huge in North Carolina. I don't know if you guys are aware of that, but traditionally biomanufacturing has got a hotspot in Boston, and there's a hotspot over in California. And so there's Amgen, Genentech out in California. There's Biogen, and I think Biogen, a couple of big companies up in Boston area. And most recently, Raleigh, North Carolina has become huge for biomanufacturing. So we've got a bioprocessing building in RTP where people come together, do things all the time. So locally and traditionally, biopharma has been very big in developed areas. So the U.S. produces a lot of biopharmaceuticals. We do. It's not like we're historically competing with India or China or somebody else to make these because they haven't had the infrastructure for so long. There are some big manufacturers in Europe, another big place, Switzerland, a couple places in Ireland, and so we're competing kind of on that level. But it's also kind of to do with our regulatory agencies. So a lot of regulatory, where you produce the drug has to do with where you can sell the drug, and so we have that kind of dynamic going too. So you can't really, a lot of places have two manufacturing facilities and they have to work together because one in Europe can sell to Europe and one in America can sell to America, and sometimes you can't cross those lines. More recently, we're seeing with single-use technology, the absence of the need for so much infrastructure in a manufacturing facility. So biopharma, I don't know if you've ever seen anything, if you've ever seen a brewery, they have these huge stainless steel vessels. Take that scale, multiply by like 100-ish, and that could be what you're making a biopharmaceutical out of. Huge stainless steel vessels, you need lots of clean water, you need to have tons of money, electricity, something can't go wrong. And traditionally that's how things were done, but now it's all single use, or it's moving towards single use. So instead of making things in huge stainless steel vessels, we can make them in 1,000 liter, 2,000 liter, which is still big, but not nearly as big as it used to be. Plastic bags, and they've got magnets in them, so you can control them. just like you would control stainless steel vessels. So we're seeing a lot more pop-up in India and China. We see have companies that come to us and ask us to design a fully single-use process so that they can do it in Africa close to the point of use for, you think about like an HIV vaccine. If they wanted to produce that close to people who need it the most, that would be in a place that doesn't historically have the same infrastructure that biopharma companies have always needed. And so you're seeing that movement towards being able to produce things in more places, which is kind of cool. Not necessarily competing, or sometimes competing, but being able to get your products to more people. And I guess the regulatory agencies probably has a lot to do with that.
Chris, can we get you next?
Yeah, can you summarize the question quickly? I had trouble hearing the first half.
It was a very lengthy worded question, actually. So that's a good challenge for me. But actually, I'm just looking for the interaction between the global marketplace, or the marketplace that your products like GoPro is being sold, but also what is the manufacturing base and what are the interactions between the marketplace and the manufacturing base? Where are you working and who are you working for?
So sorry, I'm still having trouble with the question. The interaction between the global marketplace and manufacturing, is that?
Yeah, I'm curious, is the GoPro sold in the United States or is it sold in other countries?
Yeah, GoPro's sold all over the world. I think we're in probably 26 countries or something right now.
Mm-hmm.
At least we have a good placement in about 26 countries. And we're manufactured in China, designed and engineered in the United States. So it's pretty common among companies. You don't see a lot of people manufacturing these for the obvious reasons we all know about. So, yeah, in terms of the global market and our manufacturing, we distribute all over the world. I'm not really sure what to say about it, but
so everything is pretty much single source. You have like one centralized manufacturing base, as opposed to 90%.
We use various vendors in China, so some manufacturers have strengths in one thing and other manufacturers strengths in another thing. So we recently sold a chunk, 8% of our company to Foxconn, who does all the manufacturing for Apple in China. So we have a good new vendor, and we're still using numerous other vendors. So we sell, our quantity is pretty high. We sell in, 30 billion of some things per year and stuff like that. So occasionally it takes multiple vendors to fill our quantities. My job, I don't do much manufacturing. I'm on the front end of the design, so a lot of more dealing with the actual user and testing use cases, designing the product than actually manufacturing. So the manufacturing process, we have a secondary group called Ops, and they take care of the majority of that. Of course, the vendors oversee that kind of thing. There have been some lower volume parts and assemblies that we've looked at sourcing in the United States. We've sourced temporarily in the United States just for speed. Sometimes speed to market makes all the difference. Occasionally, we will do something local. In terms of my group, we do a lot of custom manufacturing, as in 3D printing, and this is all small scale, less than 15, 20 or something, so just get it out in people's hands and test it for us to test. We do a lot of 3D printing, a lot of machining, and occasionally some short run tooling where we'll just pop off 100 of something. We may pop out 100 of something here locally and go out and test it thoroughly. But so I guess we're kind of all over the place. But the majority of our full-scale manufacturing is still overseas.
Great, thanks.
So in terms of IBM, because a lot of people, when I speak to most people, they say, well, we don't even know what you guys do. And that's probably because since we sold our ThinkPad division to Lenovo a few years back, that really was a loss in terms of our consumer market, right? So that was our product that extended for the most part to the consumer. So that's what, and still people today think of us as, oh, you make the pink bag, but you actually don't, right? But for us, I mean, we still do a lot of manufacturing. But our products go to what I call the business enterprise. So we have, for example, this, instead of a computer for the consumer, for folks like yourselves, we have the computer for whether it's NC State or Bank of America. So we have servers, that we manufacture, for the marketplace. So we still play very strongly from a manufacturing perspective in terms of hardware. We do hardware, software, and services, and we have manufacturing to support specifically our hardware and our software sites. They are global. Our clients are global. We have over 400,000 employees globally, and we have manufacturing locations in Europe, here in the United States. As well as in Latin America and in Asia as well. So we really work in terms of our manufacturing is very integrated. But also at the same time, we use contract manufacturing, depending on the product. So it's very, we have, different options, depending on, what product it is. The customer, we have actually what we call client solution centers, that where a customer maybe is buying a hardware, software, and services solution. We have these specific solution center where we actually put everything together for the client, and then ship the solution to the customer. So we even have manufacturing facilities as well from that particular perspective, given that our market has just evolved and changed over time.
Great. I thought maybe I'd ask one more question and then see if there's anyone out there who might want to also pose something. I'm really curious because all of you guys are working in pretty diverse sectors of manufacturing, and it occurred to me that maybe there's one technology that you're really hoping to get to, that there's something out there that's really going to enable things to change. And what is it, and what's the barrier right now for getting there? What is the real holdout? So, Chris, we'll start with you on the most difficult question.
The big thing I'm seeing right now is just 3D printing. So it's something that we use every single day. We use it constantly. My last job, we use it nonstop as well. So it's running rampant in the process and product design, and it's just a matter of time. Mass market. The barrier has always been cost, and it's really interesting because recently that barrier is kind of fading away. Several companies come out with printers that are less than $1,000 that can do a decent job of printing parts. So you build a computer file of what you need, you get print, and you come back in a couple hours and it's sitting in the tray, which is pretty amazing. There's a lot of concern actually with selling products in the future and IP, patent protection, that kind of stuff, when you're building your own everything. These printers are now starting to print multiple materials in a single build, so you could theoretically print. We're about to this point now where you can print the circuit boards and some of the electrical components into the plastic parts themselves and other things. You can print metal, you can print plastic. It's all over the place. So you see this a lot in industry. They're kind of an industrial process gets downsized and improved and cost reduced until it hits the mass market. It's really on its way to doing that. Once everybody can have something custom for them immediately, you just buy the file online and print it right at your house. And it's really going to change the way the world is, the way we buy things and the way we make things. So pretty interesting from a product development standpoint.
Rashida?
Yeah, so I work in the supply chain, which encompasses manufacturing and the like. And one of the things that we are focused on right now is how we can be more analytics driven, right? From a standalone supply chain manufacturing perspective, a lot of the information that we've used to make decisions have been very static in nature, right? So we really want to move to a model where we say, how can we be much more transparent across the enterprise, right? How do I know what my suppliers are doing? How do I give visibility to manufacturing in terms of when they're gonna get supply from the supplier? How can, for example, the client know where their order is in manufacturing across the cycle? And the different pieces to the puzzles, the sellers, I think are, up until this point, we haven't really had I call it open transparency, really end-to-end transparent supply chain. And I think we have to do that. In a lot of companies, in some cases, you have that within the company, but I think now it's gonna be really important to say, how do we extend that, right, from the walls of not within our four walls, but really extend that with our suppliers and also extend that with our clients as well. And the value that we'll create from getting that knowledge is going to be able to make us more efficient, more effective, as well as our suppliers being more efficient efficient as well. And I see this in terms of, think about it, envision, in the future, even analytics dashboards, right, where manufacturing is getting alerts, inventory is getting alerts. We're able to do prescriptive, predictive type of analytics to really help us in terms of making decisions, before we even have to, before there's a problem. So I think analytics is going to be really key, and we really have to take advantage of that. I think that's going to just be really powerful to the overall manufacturing, supply chain industry. And then I think secondly is social collaboration, right? And just social intelligence. How do we use, data is just out there, right? We see, things like Facebook and Twitter and these types of social technologies, but how can we use social in a more enterprise environment to be able to share data across each other? I mentioned that IBM has 400,000 employees. How do we share, reuse capital, across each other with ourselves, with our suppliers, with our clients? So I really think, if we can learn how to be more social and collaborate more, I think that's going to just be really powerful. And the mix of analytics and social together, and really marrying those two together, I think it will just really, I call it, upskill the industry significantly, and be a real big benefit in terms of value that will drive across just the entire value chain.
So there's two sides kind of that I see with biopharma. One is this push towards single use that I talked about earlier. This past year, the award for Manufacturing Center of the Year went to Biogen IDEC because they had the first fully single-use upstream-downstream facility. It was huge. That being said, it was the first for a lot of reasons. The single-use technology is not where it needs to be sustainable across the industry. We're hitting processes, and in biopharma, the product is defined by the process. You hear that said a lot. So I'm not really making a product as much as I'm making a fully controllable process. And if it goes right every time, then I get my product out of it. So it's not like my end goal is my product. Even if I got my product perfectly right at the end, if my process didn't go right, the FDA is going to stop me like a bug. Like, there's no way I can sell that. So process control is huge. So if you don't have the right things to produce your process, then that's a big thing. So single use needs to get better. We need to have better unit ops for single use technology. We need to have better films. Single use is a lot of bags, it's plastics. And it interacts with cells and microorganisms. They're living things. They need to be in a happy environment. And so if there are things coming out of plastic and messing with them, then you can't have that. They don't grow up. So the push towards single use is huge. If we can get that out and working and as efficient as it needs to be, you're going to see single use things popping up everywhere. We're having a lot of biosimilars hit the market soon. Thank you, Obama and the FDA, for saying that we can have kind of the generic of a biopharmaceutical product. So a generic protein, which does not mean that it is the exact same medicine. There's a little bit of difference. There's no way you can make the exact same protein with patents and just biologically. So you're trying to make something that's almost as similar, and a lot of players are hitting the market. They're coming in, they're trying to design processes, and so single use is enabling them to do that more fluidly, and to give it a try, because it's first to market. Like Chris was saying, if you're not in the first to market with this, the chances of you being successful are so slim, so it's really high risk for these companies. But everybody wants a piece of the pie, because these are big drugs, they make lots of money. And so single use, when single use hits and it's working properly across the board, I think that's going to be huge. The other thing with process control, our product is our process. So a lot of times, like, information is so readily available on the internet. Information about our processes is only what we can get from our processes. So a lot of times, getting information from our process is a risk step. So sampling could introduce contamination, which could kill a batch. So like if you've ever had a beer that's skunked and smells really gross, like that's a beer that's been contaminated. If you contaminate a big cell culture that's supposed to make medicine, you just can't sell it. It gets tossed immediately. So anytime you sample, you're actually interacting with that, and you could have risk. So having better sensors, inline technology, there's been a push of people learning about this thing called Raman spectroscopy, which requires a whole lot of data mining, a lot of modeling. You have to have a process that goes over and over and over again. For CMOs, it's not as useful because we only run a process a couple times. If it's commercialized, it makes sense, but in clinical trials, not so much. But if we could control our product, having better control of our processes, moving more towards a fully automated system where it's not humans interacting and making decisions, where we know what it should look like every single time, that would be super awesome for our industry. That means that it's probably going to take a while before people can actually deal with the data properly, because it's so complicated. There's so many things in a cell culture. You have no idea.
I'd like to open up to the floor if anyone has any questions. We've heard a lot of, I think, some pretty exciting detail and a lot to sum along. But anyone have any questions out there? And we'll be back.
Hey, so I just had a question about, each of you kind of talked about this resurgence of the second wave of manufacturing, and each company seems to kind of be growing in a way. And in an effort to create economies of scale, obviously businesses have to grow to lower their costs. But can you talk about how those goals are aligned with sustainability in a green way? And maybe talk about what each of your companies are doing to kind of offset growth in a very environmentally healthy way, if that makes sense.
Oh, sorry. So the question, as I understand it, was about what efforts in sustainability. I'll just use that as the first part of the
How does
question.
it align with the new manufacturing process?
And how does it align with the new manufacturing processes? Sheeta, you're up.
All right, so, well, from a supply chain perspective at IBM, we have an entire team that's focused on social supply chain and environmental responsibility. We actually was awarded a climate award by the EPA a couple weeks ago on our efforts in this space. So this is something that is not new for us. It's integrated within our process. I mean, we look at everything to make sure that we are running a social supply chain and we're responsible. It also even extends to our suppliers. So as part of our supplier relationships and the things that we do with our suppliers, we do ask for certain commitments that our suppliers need to achieve as well. So growth or no growth, right? We want to make sure that we are green and this is something that we are focused on. So it's embedded in our culture, I would say.
For us, there's been a lot of studies on single-use technology because we're using plastic bags. They have biologics in them. We can't really recycle them because they've been sullied. They go to biohazard when you're done. They normally get incinerated. And so there's been a lot of talk in the industry about whether this is the more environmentally friendly way to go. That being said, there's been a lot of positive reports saying that going single-use is actually more environmentally friendly than the traditional approach to doing things. we're consuming less because our processes are better. And the cleaning process for our stainless steel tanks is ridiculous. And having single-use and gamma-irradiated bags are kind of avoiding that. So there's a lot of different dynamics there, a lot of reasons why it is or isn't, and it's a current debate that's going out about sustainability. But I think that's the biggest thing. We're trying to do the single-use stuff, and in and of itself, it seems to be more environmentally friendly. That being said, pharmaceuticals is not traditionally very environmentally friendly. When you make something that goes into the bloodstream, it's got to be perfect. There's no kind of room for error, and so people go above and beyond to make sure things are as perfect as possible. So there are a lot of things built into our processes to make them safe, and safe doesn't necessarily mean the best for the environment. It means the best for a human body. And so having a better process design, and not having to have as many safeguards built in will make them more environmentally friendly. So the more we can control that process and we can cut out those safeguards, the better that they're going to be. So just better process design will help.
Great, thanks, Chris.
Sure, yeah. So for us, GoPro's been really crazy for the last year. So we've been selling product faster than we can make it, and sustainability hasn't been on anyone's radar at all until now. So we're finally starting to get over the hump and kind of catch up, and our CEO's kind of shifted focus to, like, he's trying to build a carbon-based company, so he really wants to be kind of the environment. But a couple things that we're doing, the biggest thing that we're doing is trying to reduce the package, because our product right now is in these big plastic packages with all kinds of bags and cardboard parts and plastic widgets. It's really overbuilt and complex. One, it'll save us cost, and it'll help save the environment. None of that. So we're going to more paper-based products like cold trays and other things. The other upside of that is a bit more product in a container. So we're shipping fewer containers and taking up less space. Really, in terms of the actual manufacturing of the product, the processes and materials we need right now kind of are what they are, and none of the bioplastics at this point are good enough for us to we'll take they're temperature sensitive and sensitive to various solvents and fluids and other things. So for us right now, we are taking steps toward packaging.
Great, thanks, Chris. I think we have time for one more question, or possibly two. Sweet.
Do I need to use a microphone or that's fine?
I think we can hear, but I'll repeat for Chris.
Okay. It's more like a comment. I'm on the faculty of industrial design here on NC State, and half of the audience are industrial design students, so I'm very proud of them. But one thing is, there's a lot of discussion on 3D printer, on 3D printing. Just one more observation of mine is, I was in the manufacturing business for more than 12 years. And it's exciting, it's interesting development, but it's not going to be a solution in a short period of time. Because if you look at the product around you, there are a lot of materials, and it's a mixture of metal, plastic, polymer, all kind of things, including circuit. It's not, even though probably 5 or 10 years, we might be able to print an iPhone or even a car, but it's going to be impossibly expensive. So it's not going to be a solution in a short period of time. So looking at our competitiveness, so we still have to think very hard our advantage. So 3D printing certainly offers some solution, some interesting development, but it's not going to be a solution in a very short period of time. And also, that's something we can look at. On the other hand, I'm a little surprised by the how many people are here this afternoon. We have a huge engineering school, and we have a lot of people, students going to be involved in manufacturing later on, but we have only a few people here today. But one thing is, in China, in India, they've been doing very well in manufacturing, but in the meantime, they are looking at expanding their spectrum. They are looking at into the research and development, and just like everybody looking at other places. Okay, China is interested in doing high-end products, like United States, and United States trying to bring some manufacturing back here. It's very interesting development, and it's time for us to think how we're going to play. So what's the model we're going to be working on? One thing is, one possibility is we have to look into what kind of value of the product we need to manufacture. So, for example, in Japan, they make injection molding machine, but they also buy injection molding machine. So it's a very interesting why they have to buy and sell. They buy low cost, low-end manufactured injection molding machine from other countries, including China. But they make very expensive, high-end injection molding machine to sell to countries like United States. In Germany, it's the same thing. They buy cheap cars, but they make high-end high-end cars. So that's something we are looking at. We bring back manufacturing, but what kind of manufacturing we should be bring back? 3D printing might not be the solution. It's going to be value-added, high-value products we're looking at. So that's kind of a thinking I think probably I would. The other thing is the industry, biomedical products, medical products. There are many products we have advantage here in North Carolina, but just be careful what we are wishing for, what manufacturing we are bringing back. Haier is a huge appliance company in China. They brought a refrigerator manufacturer in South Carolina. We don't see a lot of benefit bringing to South Carolina. But there are some manufacturers we do, like biomedical medical products, we have an advantage. That's something we need to take advantage of. So that's my comment.
That's fantastic. Yeah, good comment. I don't want to make us late for the rest of the day, so I think that might be a good stopping point. But we have a break coming up where I think maybe some of these ideas can be shared one-on-one. And what I also heard was a call to action for all the students here to text one friend who's in engineering school and have them come to the next panel discussion. So big hand for all our panelists.
We're going to take a 15